Okay, good afternoon, everybody. I want to welcome you to the sixth annual Entrepreneurial Impact Competition. We started this in COVID, so I'm really glad that we're able to do it face-to-face in the conference room here. This year, we're excited to celebrate students' innovative ideas. We, as I said, started this in 2021 as a way to boost the spirit of entrepreneurship among our students, and they certainly have risen to the challenge. As I'll explain, this year was kind of exceptional. The 2026 finalists that you'll hear from today were selected from an open call for proposals at the beginning of this semester. Individuals and teams of students at both the undergraduate and the graduate level were invited to apply with their entrepreneurial ideas that would help to improve the human condition. Following a thorough review from our panel of judges, who will be introduced in a few minutes, 4 finalists were selected from a highly competitive pool of 17 applicants. Today, 2 teams will be chosen to win a $5,000 prize. Those are sponsored by our generous donors, Bill Higginbotham, who's here this afternoon, as well as Greg Zeitlin. The Zeitlin Innovation Award will be awarded to the team based on their creativity and merits of their project at any stage of development. The Higginbotham Entrepreneurship Award will recognize a team with a more developed project, emphasizing their endeavors to bring the concept to market. Over the course of tonight's event, each team will pitch their idea, then answer questions from our panel of judges. The audience will have opportunity to ask each team questions during the judges' deliberation break. With that, I'm going to turn it over to our MC for this afternoon, John Taylor. John Taylor is the Associate Chair for Faculty Development and Research Innovation in the school, and he holds the Frederick Law Olmsted Professorship. Dr. Taylor is actively engaged in entrepreneurial activities through his own research and is a co-instructor of the Innovation and Entrepreneurship in CE Systems course. So I'm going to pull John up here to the front.
Thank you, Don. So we have all of our finalists here today, excited to present their cool innovations. Maybe I need to be further from here. Please join me in welcoming our 4 finalist teams. So there are 2 awards here, so I'm going to introduce the teams. The finalists for the Zeitlin Award, which I'm going to explain in a moment, are first DozeOn Technologies, Alani and Andrea. Do you mind standing? Yay. So also for the we'll do clapping at the end. You can sit. Also for the Zeitlin Award, we have OmniTherm and Veda, Eden, Amaniel, Bin, Adrian, and Roshni. Can you stand? That's a big founding team. So tour de force here today. Thank you. And the finalists for the Higginbotham Award are apparently on the other side of the room from Bill. Fearless, Aarosh and Sumit. Can you stand? And then the 4th competitor, also for the Higginbotham Award, is HydroLoop. So Anuj and Ravi, can you please stand? So best of luck to all 4 teams today. I want to introduce our panel of judges as well. We have a distinguished panel of judges, alumni of the School of Civil and Environmental Engineering, who have had successful careers and are going to kind of share that wisdom to quiz you all about your startups and determine who are going to be the winning teams. We have first Kelly Brown, Senior Program Management Director at Turner & Townsend Heery. Welcome. Scott Johnson in the middle, President of Civil Design Solutions. Garland Long, now we're going to zigzag through the board here, through the panel. President of Lakeshore Engineering. Elliot Siegel, who is a Managing Member of Vision Metals. And finally, Jack Walls, who's the Principal of JWA Project Management, LLC. So I'd like to extend a huge thank you to the judges for joining us this evening. I'm not giving details about each individual, but we have on the Entrepreneurial Impact Competition website details about their entrepreneurial journey. So I would encourage you to go learn more about the judges. So thank you all for coming and doing it. So we're going to begin with the presentations. Each team will have 5 minutes to present their proposal. The presentations will then be assessed by this panel of judges on how well they satisfy 4 criteria. The criteria are innovation, value proposition and impact, communication, and probability of becoming a successful entrepreneurial endeavor. These 4 criteria will be used for both the Zeitlin Award and the Higginbotham Award, but they'll be weighted differently. The Zeitlin Innovation Award emphasizes the potential of a project. The winner of this award will be recognized for the merits of their concept at any stage of development, whereas the Higginbotham Entrepreneurship Award recognizes the relative maturity of a project. So these winners will have identified and tailored their concept to specific end users with an emphasis on bringing that concept to market. So we have the Higginbotham finalists over here and the Zeitlin Award finalists over here. After they present, the team will be asked questions by the judges. Each judge will be allowed to ask 1 question. We have 10 minutes set aside for judge questions. Judges can ask more questions if time is permitting. And this year, we've invited the founders of the awards to also ask a question. So please welcome Bill Higginbotham, who endowed the Higginbotham Entrepreneurship Award and was instrumental in creating this very competition. So I clap for Bill. Okay, enough upfront materials. Let's get to the actual presentations. First up, we have OmniTherm. This concept, again, is a Zeitlin Innovation finalist, and it will be kicked off by Adrian Trujillo. I welcome the team to the front. It's all yours.
Hello, my name is Adrian, and alongside me are Ben, Veda, Amaniel, Eden, and Roshni. Before we begin, I would like to ask a quick question. Please raise your hand if you or anyone you know has ever received a vaccine. Take a quick look around, nearly everyone's hands were raised. We all understand how vital vaccines are, and yet we are facing a staggering crisis. Up to 50% of vaccines produced globally are wasted every single year, with a large portion of this waste happening during the final stage of vaccine transportation, from district stores to local clinics to patients. This final stretch is known as the last mile. Specifically, vaccines spoil most often due to temperature spikes. And last mile healthcare workers are expected to deliver and administer these vaccines in extreme conditions where temperature spikes often occur. For example, if you look at the top right image, you'll see healthcare worker Sheba administering liquid polio vaccines in up to 40 degrees Celsius heat. Now, if you go down an image, you'll see Nazrul Islam, a healthcare worker in Bangladesh, struggling to load vaccine carriers onto a boat for his trip to a remote village. As you can see, this problem devastates underdeveloped and rural communities, fueling a global health inequality where up to 67 million children miss their doses per year and millions more life-saving care.
To combat this issue, my team and I developed OmniTherm, a fully passive, reusable vaccine carrier that is engineered to keep vaccines safe without relying on a fragile power grid. Current UNICEF carriers can only last 40 to 45 hours, and their biggest carriers offer just 3.4 liters of usable space. However, at OmniTherm, we can last upwards of 53 to 61 hours consistently, and we offer up to 5 liters of usable space. On top of that, we've also added new backpack straps for easier transportation, and we've also included vacuum-insulated panels that are lighter and better than traditional insulation. Attached to our vacuum-insulated panels, we have our phase change material boxes, and inside those boxes, we have 2 things. We have our phase change material and our interior skeleton. So what are phase change materials? Phase change materials are substances that absorb a lot of heat when changing states of matter. The specific phase change material that we use is a specific 7:3 lauridic acid to decyl alcohol ratio because it maintains the perfect 2 to 8 degrees Celsius range, ideal for freeze-safe vaccines. Moving on, we have our interior skeleton. This interior skeleton is a graphite-coated gyroidal frame that is meant to increase our thermal conductivity of our phase change material. Additionally, it ensures even heat distribution throughout our PCM box. What this means is that unlike traditional carriers, traditional additives that include expanded graphite and nanometals, this structure prevents clumping and hotspots, addressing reusability and making our product last a lot more. What this all equates to, this technology of PCM and optimized geometry, gives us our 90% reduction in phase change time, giving us our biggest advantage, speed. Current carriers take 2 to 3 hours to stabilize after a temperature spike and take upwards of 24 hours of freezer conditioning to be ready to use. However, at OmniTherm, we change that. We take only 30 minutes to an hour to stabilize, and we require just under 4 hours of freezing conditioning to use.
It may seem technically dense, but what this all boils down to is a faster, safer, and more reliable vaccine delivery. Now, let's talk about who needs this and the scale of that need. OmniTherm's primary customers will likely be global health organizations, including UNICEF, Doctors Without Borders, and national health ministries in low and middle income countries. And the numbers make this demand clear. UNICEF alone has delivered over 1.1 million vaccine carriers since 2019. That's the market we're entering in, and we enter it with a product that outperforms major competitors like Nicamol. OmniTherm directly addresses UN Sustainable Development Goal 3.8, universal health coverage. With OmniTherm, workers like Sheba could travel farther, carry more doses, and be worry-free about losing a shipment to a temperature spike. At $400 per unit, OmniTherm is financially accessible to NGOs and government procurement programs. And at $86 per cost of goods sold, we have strong margins that allow us flexibility of scale. With your investment of $140,000, we project that we'll break even by mid-year 2 and surpass $1.8 million by year 7, making us a promising investment. Unlike traditional refrigeration systems that require stable electricity and costly maintenance, OmniTherm needs nothing but stable freezers for under 4 hours. That means we're deployable anywhere by anyone at a fraction of the long-term cost. So what do these numbers mean in real life? OmniTherm's 53 to 61 hours passive cooling makes us roughly 30% more effective at vaccine spoilage than our current carriers. That means if adopted universally by UNICEF alone, we estimate that we not only save $50 million annually, but the lives of 330,000 children every single year. At OmniTherm, we know that every great journey has a last mile, but we try our best to make sure that no vaccine and no life fall short of it. Thank you, and we're open to any questions.
Well done plowing through the microphone issues. Certainly not going to hold. We'll start off with maybe at this side. That would be great.
Thank you again, and wonderful presentation. Absolutely great with the way that you presented and your voice and making eye contact. That was definitely excellent. My question has to do with your startup cost and the loan of $140,000. Can you please go into a little bit more detail of what's included in that cost and what you think, if you look back now, what maybe you forgot to include that you would? Thank you.
I think mainly with this microphone doesn't really work, but yeah, mainly with the startup loan, what we plan to do with that is work on a lot of our research and development costs, because the reason that this product hasn't been really put in place is because a lot of this research is relatively new. So what we want to include in that mainly is doing our research and development, figuring out why this hasn't necessarily been used and how we can make sure that it's optimal. And so that in that market, we can make sure that we make our own space, gaining that customer loyalty and lowering that threat of new entrants. So we can really make our mark. But to address your question about what we may have forgotten, our financials doesn't necessarily encompass entirely the factory costs, because again, what we really wanted to focus on, especially since this is a Zeitlin innovation, we wanted to mainly focus on our idea, making sure that this is something that's truly feasible, and how we can eventually go on from here to a solid product. But thank you. Thank you.
So, like you said, good job, everybody. Good stage presence up there. So, what comes to mind to me is, how do you know it works? How do you know it maintained the temperature? Is there something that you put in there that you can be able to show that it did work and it never got above the optimum temperature?
Oh, okay. So the reason why we know this works is because there's already a lot of research talking about like interior skeletons, specifically with like PCM carriers. But the only issue is like, this is a very difficult concept back in the day to like bring forth, but given like new manufacturing techniques like 3D printing, it's something that we can like create now. And so there's already a lot of like research showcasing that this is a very like true thing that can like work effectively. And I think it is just something that's like been proven through like years of research and that we're trying to like push forth now.
Scott?
Great job, guys. Everybody did great. One quick question. Have you guys looked into the sort of regulatory hurdles that you may have? What about like any sort of FDA approvals or WHO approvals for your product? Have you guys looked into those sorts of things?
I can answer this one. I know specifically we've really only looked into like being UNICEF approved, and being UNICEF approved is like a very like hard thing to do. You first have to like submit your patent, you have to submit your product, and then afterwards you have to go through like multiple stages of like approval, and you have to submit a lot of documentation, the cost, and like what your product actually does. And I think I remember when I was looking on their website for like their specific PCM carriers, one product takes around like 5 pages of documentation. And so specifically we looked at UNICEF, but we've not looked at anything like the FDA approved or anything like that.
I believe UNICEF's website also mentioned that you'll also be FDA approved. Excuse me. There's a little, I forget what the machine is called, but there's like a node you insert within the PCM box. And there's like a screen outside of it where you can measure the actual temperature. And I believe it's like 2-3 weeks of trials. You need to consistently prove that. Of course, you can last within that range of 51 to like 60 that we're claiming. So that would be like another regulatory.
Okay. And one last question, and you may have said this and I missed it. How many doses would one of your carriers hold at one time?
So in traditional UNICEF carriers, they're 1 liter, and in 1 liter boxes, you can hold up to 700 doses of like polio vaccines. And we estimate we can hold up to 5 liters. So that was just like 5 times 700 is what, 3,500, right? If my math is correct. But also another thing we want to emphasize is the fact that it doesn't mean we can just carry more doses. It's also to supply other medical supplies, because there's no way that one healthcare worker could possibly administer 3,500 doses in one day. And so our increased space also allows for medics to carry like bandages or any other medical supplies, not just vaccines.
There were some excellent projects, so congratulations for making it this far. So I had a question. You talked about this being a last mile solution primarily. I would imagine a lot of the places where this would be implemented might be having other power grid related issues possibly. Did you do any data research to see how long some of these outages would last to make sure that the time frame still is extremely viable in real application?
We knew that temperature spikes are caused a lot through power outages, and so we wanted to address that without even including power in our like system entirely. Like the only source of power we would need would be the initial freezer to maintain and like condition our product, but then after that it would require no power for the next like 52 to 61 hours. And so that would be the only case. And of course, like because of how accessible our product is, any standard freezer like could condition our product under 4 hours.
So I was wondering on the question of the number of doses that it carries, how does that compare to the current methods? And is it more efficient in the number of doses that you can deliver, or how does that work?
Yeah. So it is definitely more efficient in the number of doses that we can carry because we can just carry more. And also it's just easier for people who do transport them with our backpack design. And so we're able to go to farther places and like in easier places because we also last longer. And so what that equates to is just we're able to reach more areas and administer more vaccines, but also deliver more medical supplies. Like let's say, for instance, we keep using the standard 1 liter or the 3.5 liter UNICEF box, like 3 times the 700 is what, 21,000 doses. We can still keep 21,000 doses, but then we still have 2 extra liters of space to carry other medical supplies.
And I think a really important part of our new project, or what we've added to this carrier in the first place, is those backpack straps. It seems simple in design, but what it really does is it allows all of these people who are delivering these vaccines to go to places, carry more than they traditionally would have been able to. Some of the pictures we didn't include, we've seen deliveries happen in freezing conditions, deliveries happening in deserts. So having a accessible prototype like this, or not a prototype, sorry, but a product that allows them to carry so many vaccines across any kind of terrain, really, and makes it simple at its core. It's a really strong part of our project.
Well, is it because the storage is more efficient inside the box than in the others? What's in the old boxes that cause it to not be able to carry as many vaccine doses? Is it just bigger?
Yeah, I can speak on this. So the old vaccine carriers, their installation is very, very bulky. And that's why we changed to vacuum insulated panels, which are lighter. For one, that makes it easier to like carry and deliver them. And number 2, they just take up way less space. And also because of how efficient our PCM is, our PCM boxes are significantly lighter than like traditional coolants that they use in SF carriers. And so we just have a strict amount of space, and also our box is just lighter.
So how are we on the 10 minutes?
2 more minutes.
2 more minutes still for this group. So you were continuing. Go ahead if you were continuing.
That was
Okay. So do any other judges want to follow up with additional questions?
This is obviously it's a very what's y'all's background? This is very extremely interesting and probably a little unfamiliar to us here. So it's very impressive, but just kind of give us how did you even come up with this idea?
Yeah, I think one of our biggest strengths as a group, I know we're a really large one, but we all come from multidisciplinary backgrounds. So 3 of us are civil engineers and 3 of us are from other backgrounds. I'm a finance major, so I mainly worked on a lot of the financial stuff. Adrian?
My background is in civil engineering. I was able to use that background to focus more on the ethical side of it, focusing on sustainability and impact of this project, as well as the transportation aspects, such as the backpack strap.
I'm an industrial engineer, so I mainly worked on optimizing our script and our proposal. So I worked on fixing the communication so it seems more clear, because it's a very complicated topic. So more clear, easy to read and understand. And I also helped conduct research, so strengthen the credibility of our solution.
I'm a civil engineer, and this project really related to my interest in sustainability. And so that's why I really wanted to go forward with this project.
Yeah, my background is in mechanical engineering. So the model you see here, I designed. And I worked with a lot of the manufacturing process, just sanity checking, a lot of the research, making sure it's actually feasible, something we can actually do.
My background is in civil engineering, and I helped with a lot of research development and technical direction of the project. I also did a lot of research and had a lot of conversations with one of my professors, Dr. Shane Snyder, and he has an extensive background in global health in developing countries. And I'm in his class, Engineering Technologies in Developing Countries. And through these conversations with him, I was able to have more of the overall well-rounded lens and how we can really use sustainable resources.
Great. So great last question, Elliot. Great questions from the judges panel. We now have time for founder of the award question.
It's a 2-part question. Various elements of technology in your design. How many of those elements are available for some form of intellectual property protection? Second half of that is, what have you done to date to ensure that it is going to be protectable?
This is something new that we have not really patented yet, but we are planning to do that. I think my colleague Guy can talk more about that.
Yeah, so with the 5,000, we would want to think about funneling that money more into the research and development side of our OmniTherm. So while we do have claims about that our product can significantly increase cooling time, we still want to physically validate that. And so what we would mainly invest in is high fidelity prototyping. So that would mean actually purchasing those LADA PCMs and the carbon filament, so we'd be able to 3D print our variable structure. But this isn't just about proving technical claims. It's at the end of the day, it's about reducing that 25% of vaccine spoilage and overall saving lives of 100,000 people across the globe.
Sorry. And in terms of intellectual property of the product, I would say the gyroidal shape inside the PCM cooling system. I think that would be something we could claim as our own, and we could develop into a greater idea.
But yeah, we haven't necessarily looked super into the intellectual property aspect of it. And I really, I appreciate that you asked about that, because it's definitely something that we would look into in the future. But yeah, so our idea hasn't been necessarily implemented before, but we definitely do more research into the intellectual property aspect, or if our product maybe goes against any claims that were already put out there, or any patents or anything. Thank you.
Yep. All right. Great job, OmniTherm. So we're going to take a moment to figure out the microphones. And you all can start coming up. All right, so now we have our second Zeitlin Innovation finalist to present, DozeOn Technologies. I believe Alani Allen will lead it off. Alani, you may begin your presentation.
Good evening. My name is Alani Allen. This is my partner, Andrea Lewis. We're both civil engineering majors, and we represent DozeOn Technologies. So the construction industry, unfortunately, has the highest workplace fatality rate in the world, and more than 1 in 5 fatal incidents occur every single year within the U.S. And as you can see in the figure here, the fatality rate within the U.S. construction workplace has been on average increasing over the last 10 plus years. Now, most of these incidents have been related to heavy equipment use. So struck by and caught between incidents are the cause of this, and that is because of equipment blind spots and lack of real-time proximity awareness for the operators. And knowing that, we know that all valuable entrepreneurial efforts require real need, and we see that the construction industry, safety in particular, has a clear gap in improvement. So keeping that in mind, our DozeOn technology safety system is a retrofit multi-sensor system that is comprised of thermal and LiDAR sensors as well as cameras, and it is integrated using YOLO V8 software through a user interface. Now, the user interface will be depicted as a screen inside of the cabin for the operators. And additionally, as shown in the picture, these cameras and the sensors will be placed specifically around every piece of heavy equipment to provide the operators with a 360-degree view of what is happening around them in real time. Now, we know that distractions are a big factor for operators because they are doing so many things at once. So we decided that we are going to reduce our screen size and additionally split the screen into 4 different quadrants, where our alert system will be a flashing red light, and it will identify exactly what is happening in that quadrant or quadrants so that the operator knows how to act. Now, our mission itself is to improve safety within the construction industry, but also to ultimately eliminate hazards by helping operators to see, sense, and stay safe. Now, knowing that one of our duty as engineers, particularly as civil engineers, is to work towards safety, we kept in mind the United Nations Sustainable Development Goal number 3, which is good health and well-being of all people within the communities that we are working in with this product. And in order to promote not just compatibility, but also the longevity of our safety system itself, we designed these miniature shock absorbent mounts that are going to be used to mount our screens in cabin based on shock absorbers that already exist. All of our cameras will be covered in a glare resistant lens, a shock resistant lens, shatterproof lens, and then additionally, all of our wiring is going to be this highly flexible wiring that is covered in a nylon conduit, and it is also covered by shear strain resistance.
Each component of DozeOn is driving our competitive strategy. Within that, other companies that are listed have partial solutions. However, we are the full package. So within our retrofit design, our cost can be kept at $4,000 to $5,000 per unit. And this is we deliver this through our safety system, which is going to be used across mixed fleets. So DozeOn is positioned uniquely within the space of affordability and versatility. So looking ahead into the future, we have identified in our market analysis for the total market at $224 billion, the addressable market at $1.6 billion, and then the target at $8 million. So here at DozeOn Technologies, we are not just an idea. We are looking towards creating this as a full prototype. So through CreateX, we have enrolled ourselves in their idea to prototype course, where we are creating our preliminary prototype. Also, within our industry feedback from our customer discovery, we have received overwhelmingly positive feedback from the listed companies, and we have also been invited by a few of them to bring forth our preliminary prototype to do beta testing. Thank you so much for listening, and we are opening the floor to questions.
Great job, DozeOn team. So maybe we'll move over one and start with Garland. Yes.
Figured you picked me on purpose. So I'm in the heavy civil business. So we have quite a few pieces of equipment out here. So I could definitely see whether this is something that could be very useful, and obviously keeping people safe and saving lives is very important. So first thing that comes out is $4,000 or $5,000 a piece. So, you know, the average life expectancy on these pieces of equipment are a couple years. We'll trade them for tax reasons, other reasons as technology changes. So after a couple years, does that piece of safety equipment come off and then go on the next piece of equipment? Do you see it going with the next one? Who's going to offer the training on this? Who's going to do the upkeep on it? What have y'all considered in those things?
Okay, sure. So I will say that we have definitely worked out more of the financial portion than what is outlined here. But in our prototyping process currently, we decided to kind of pull back on that a little bit until we're a little bit more absolutely certain about what our prototype is going to actually look like, given that we have been offered to actually test the product in person. So we know that these things can be very expensive. And what we have identified it to be is that it will come together as an installation kit. So training will be included by us, installation will be done by us, like the price will be all inclusive of everything. So within that, I guess legality wise, we'd have to work out replacements and that sort of stuff. But this is something that, again, would be retrofit and potentially reusable.
Yeah, so to kind of go back off of that, there is about $1,000 O&M cost that is included within the $4,000 to $5,000. Additionally, because it is retrofit, we are able to come and take it off of whatever fleet or heavy equipment that comes with. Additionally, we provide a manual that kind of has like a link to like whatever our training video is, similar to like toolbox talks or like safety moments. So yeah.
Yeah. And additionally, we know both of us have taken various construction classes, and we know that new technology can be very difficult to implement on construction sites, rightfully so. So with our technology, it would really require minimal additional knowledge. It's really just for the operators to be able to see and react accordingly as they would if they were to just see it just with their own eyes. So relying on their training rather than additional training for our product.
Great job, guys. Good presentation. Can you expand just a little bit on the industry feedback from these companies? In particular, was there any sort of feedback that you chose not to include in your product? Any major components that you had not thought of that they brought to you? Can you just expand a little bit on that?
Yes. So within the construction industry, we have talked to mainly director of operations, safety directors, and like senior superintendents. So they were able to give us direct feedback into what they see in their day-to-day lives on construction sites. So again, it was primarily positive. However, we didn't really receive any negative feedback. What we've received would just be like, we're not sure about how our company specifically would be able to implement this. However, we see the need for it. Additionally, I would say Jacobs, for instance, this man that I talked to, he was the safety director in Tampa on like the international airport or the airport in Tampa. And he was just like, we would love to have you guys come out and put your stuff on our heavy equipment, and we can bring everyone here to talk to you just to give us more of what it is. He said, because he's seen so many fatalities in his career. I think he was working for about maybe 50 years within the construction industry. And he just said he believes so much about our product and in our product, because there is, again, like we said, a lot of need.
Yeah, and I will also just briefly say that it was mostly positive feedback, but there was also feedback that we incorporated. So definitely feedback from you all, but additionally feedback from the actual industry was what made us keep in mind how difficult technology can be to implement on construction sites.
Yeah, not only are we innovating this as a product, we are continually trying to innovate ourselves as DozeOn Technologies to meet the needs of the market.
So safety is always, it's like it never goes away. There's always issues. I think all of us probably here deal with that on a daily basis. To me, safety is always about what's the right focus that's going to really drive results rather than just going through and checking boxes. So I think the start is excellent, and it seems like your technology is heading in the right direction. But have you considered ways to also help the operator out with a little bit more, you preventing the operator from doing something rather than either missing something, even though it's on the screen right there? We're all humans, and humans tend to make more errors than if they get some kind of an alert or feed that actually prevents them from doing something.
We haven't looked into that specifically. However, that is something that we can definitely look into. So do you mean more so like some cars, they have like a heavy brake if you don't brake?
Exactly.
Okay.
Yes. That seems to be the direction that automobiles are going in that direction.
Correct.
Right?
Yeah.
It's just very similar. You have human beings operating. An automobile is a heavy piece of equipment, right? It can do a lot of damage. And the focus is on making those safety. It's kind of taking the human element a little bit more out of it and pushing more on available technologies that are coming into play.
So I definitely think that would actually it's an interesting thing and definitely an important thing to maybe try and look into implementing. But I think that given the direction that we're going, it would actually be quite an easy thing to implement. So the YOLO V8 software that we're currently testing and using to produce our prototype, like we had in our proposal, does actually use AI as a preventative software and other measures. So I definitely think that's something plausible that we could look into including.
That was one of my questions in reading your initial reports was, are the operators going to be too distracted by all the video and stuff? And I was looking for more of a tones and tactile feedback rather than having 4 pictures up there. I don't know what direction they're really pointing in.
So the idea behind it wasn't, so the YOLO V8 software is taking in all of the sensors and all of the information that it's giving, and it's essentially like flatlining all of the data so it can output a tone and a flashing light so the operator has minimal distractions. So the quadrants and or pictures that are kind of pictured is just to coordinate with where on the dozer, for example, that the hazard is present.
Can you go back to close? So if you look at the actual screen there, you can see that the actual people in the way or the identified quote unquote hazard is outlined there for them in red. So a large part of the point as well is also so that they don't have to kind of guess what's happening around them. It's going to be trained to outline for them exactly what it is that maybe they're preventing or what is exactly happening right now.
And in further risk mitigation, as DozeOn and protecting DozeOn Technologies, we are offering awareness to supplement the operator's competence. It's not a replacement for their competence.
And quick follow-up question. Who do you sell it to? Do you sell it to the people manufacturing the equipment? Is it going to be, you used to buy a backup camera and stick it in your car yourself. Now they're starting to all be integrated. Is that going to happen? Is that where this is headed?
Yeah, so one moment. So our addressable market is for the heavy civil site work that is available, which is $1.6 billion. And so our target, which is 0.5% of that, is for the construction firms and heavy civil contractors that are willing to adopt our retrofit safety system.
And then, right, so the whole point was starting pretty small and then scaling up that way.
Yes.
Okay. Thank you. Kelly?
A little bit more about your finances and what's in them right now and how you came to that point. Because I thought I heard you said you really haven't priced out the actual equipment, but please explain what you have priced to date.
Okay, sure. So we previously we were not including LiDAR sensors in our initial product. It was more so just thermal sensors in cameras. But now that we're including LiDAR sensors, we wanted to ensure that that was the best option for us and then go back through the finances. So that's what I was saying. So we just scaled up our initial pricing, which was based on that at-home installation kit with, or not at home, but the installation kit with just the thermal and the cameras in addition to the LiDAR sensors. But we haven't looked into what the specific new price would be is until we get that final prototype.
Yeah, so like our our financial projections are a little blurry at the moment because of the addition of the LiDAR sensors. However, included in like the $4,000 to $5,000 range is the O&M costs, the sensor cost, as well as the subscription to the software that we use to integrate all of those sensors together.
All right, thank you guys. I think we need to move on now. I'm being told by the timers to the founder question.
This is more of a suggestion than it is a question. Your customer discovery focused on construction management firms who don't operate equipment, and safety is a mom and apple pie issue. Everybody's going to say we want to be safer than we have been in the past. The main equipment manufacturers to which these devices would be connected, Deere, Caterpillar, any number of major equipment manufacturers, they have enormous power in the marketplace. They can accept this or basically reject it. That needs to be a major portion of your customer discovery because they spend decades and millions of dollars on cab design, functionality, and now you are entering their space. So it seems to me like there's an entire body of homework that's got to be done about how to do this, how it integrates with, for instance, a GPS controlled dozer. Are you a friendly applicant to that, or are you a conflicting applicant? So I would, again, it's not a question, but I think it's a major area of focus before you, and it can take place as you are prototyping the first device so that it can be explained. But you've got to be compatible with the manufacturer base first.
It's a very interesting point that has not yet been brought up. So thank you.
Okay, thank you, DozeOn. Now I would invite up the first Higginbotham Entrepreneurship Finalist. I believe Aarosh Dahal is going to start off the presentation. I think both of these microphones work. Just don't use this one up here. And this company is Fearless.
Imagine designing a bridge, an aircraft, or even a simple mechanical part. But instead of spending hours learning complex software, debugging the finite element code, and setting up the simulation, you just describe your problem in plain English and the simulation runs itself. That is the future we're building with FEAI. Finite element analysis, or FEA, is the backbone of modern engineering. From skyscrapers to satellites to computer chips, it is quite literally the engine behind every design. However, the tools that we use to run it haven't changed in decades. Now, we have all heard about LLM. An AI agent takes that a step further. An AI agent is an LLM connected to tools and memory. Today, AI agents are running customer support, conducting research, writing and debugging software. They break complexity into small manageable steps, and that is exactly what FEA setup demands. FEA, as we know it, has a huge problem, not in its capabilities, but in its implementation. The capabilities of FEA are kept behind huge paywall, steep learning curve, and the necessity of powerful hardware. It means amateurs who want to build cool stuff are locked out. And it means for experts like myself, the problem setup is menial and repetitive task. You are configuring things that you have configured 100 times before, but we have a solution.
So introducing FEAI, an agentic AI-based system that takes in the simulation description in plain English language and then generates and automates the entire end-to-end FEA pipeline. So this is how it works. First, the chief engineering agent takes the user prompt in plain English language, and then it distributes that into a group of specialized sub-agents, which are responsible for tasks such as properties assignment, doing the mesh generation, running the physics engine, and handling the post-processing of results. So to understand the benefit of FEI, we conducted a user study with an undergraduate civil engineering student and timed each of the steps. And we found that using FEA AI actually saves 3 hours and 45 minutes of manual simulation setup effort as compared to the other market competitors like Abacus. So this is not just automation. This is democratizing the whole simulation for everyone. So there is an inherent challenge, and that should be obvious for everyone. That is, language models and AI systems are stochastic in nature, and their results are probabilistic. So can we really trust an AI agent to generate this complex physics system? And the answer is no. We can't and we don't. That is where we innovate with another approach called retrieval augment generation, or RAG. So what RAG does is, instead of generating physics from scratch, it takes in and reads it from a database of thousands of verified and validated finite element engines, which are approved by industry experts and researchers in the area. So the AI is not hallucinating physics. It is rather matching a problem with the best set of solutions and then assembling them together.
And it works. Let me show you. We give FEAI a simple prompt with this figure. Tear this sheet of graphite by pulling on top and bottom. And like any human would do, it goes to the web, searches for material properties of graphite. Like any good engineer, it gives us updates about what it is doing at every single step. It generates the mesh, it builds the finite element model, and finally, after running the simulation, it gives us the output from one single prompt. What you're seeing on screen here is not a mock-up. It is real, actual output from our framework. If I was to run an FEA simulation for this exact problem, I would have done the exact same thing. And I would have gotten the exact same result by spending a lot more time.
So looking at the numbers, the FEA market hit $6.8 billion in 2025 and is increasing at an annual rate of 9%. And the top two players in the market are Abacus and Ansys, which cover a market share of more than $100 billion. But their limitation lies in the main limitations in terms of the expensive licenses, the inflexibility of the physics engine, and then they assume that users are experts in using their tool. This is where we did a market survey to understand the demand, and then we found that more than 80% of undergraduate students actually favored on using FEAI. And in terms of researcher, we got 100% yes. Based on this, we divided our current revenue sources into 3 tiers. First is the enterprise FEA for industry experts, for the individual subscription for researchers and freelance engineers, and pay-as-you-go model for the early learners and occasional users. And our main investments right now are going towards LLM API, cloud compute, and then the product development. So we have a clear 1-year roadmap ahead of us, targeting from initial development to deployment and then scaling our business. And you are all our portal to a sector that we want to tap into. So to conclude, FEAI actually combines the power of current agentic AI advances and brings that to FEA to make FEA much more accessible and efficient. This is Team Fearless signing off with the aim to democratize FEA for everyone. Thank you.
Fearless through the bell. Okay, we'll start with Scott.
Great job, guys. Will you please address where you are with intellectual property rights and patents and that sort of thing? Have you started working on that kind of stuff?
Yeah. Right now, I'm the only one using this tool. I actually do research in FEA, and I plan to develop this for my workflow. And as of now, the tool that we have developed, that we saw the output of, I'm the only user. And in the next month, we're planning to expand it to our lab so that everyone can use it. As of now, we don't have a patent yet. Our novelty comes from the retrieval augmented generation part of it, which no one has done before. So we're looking into filing a patent like really soon.
Excellent presentation. So my question is, and I know you're kind of early on here, but like the analysis, are you talking about simple structure analysis, or are we talking about complex framing type of design and analysis? And how far away are you from being able to get to that point where it's really implemented in the workplace?
So the usefulness of this tool really depends on the clarity in the prompt that the user puts in. Let's say you describe a problem. Let's say you have to design a steel frame. It has a lot of parts, right? So you'd have to, like you do with any other software, you will have to describe what each of the member is, what the geometry is. And if you clarify all of the prompt really clearly, it does it really well. Now, let's say you don't give it the length of one particular member. Then it is going to ask you, there's a missing length. Do you want to put it in? And if you don't, it is going to assume it and just carry on with the simulation, right? So for really crucial work, it is important that the user is really clear in the prompting part. And if that is done, it works with like really complex structures.
Yeah, and just to add on that, so since it's a language model powered system, so basically it is going to guide you as well in the process of, based on the other prior analysis that it has run, it is going to guide you in terms of what you might be missing and what you might want to add in, right? So it will help you through the steps so that even students or early learners who are learning this makes it easier for them.
I'm on the construction management side of things, and we just hire you guys with the design side. How would a structural engineer design this building using this? I'm still not clear on quite how that should work.
Right. So design is a layer on top of analysis, right? So first you do the analysis of a particular structure, then you get the stresses from there, and then based on those stresses, you refer to some codes, let's say ACI or ASCD, some codes out there. So a design software is a wrapper on top of a finite element software. So what we're building here is more of the engine part of it. Sure, we could expand it so that we could include the design part, but this is more about the engine. How would a structural engineer use it right now? To just for the analysis part, let's say I'm designing a chair and I want to figure out if when I sit on it, it is going to break or not. Then I could just give it the geometry of the chair and the load that is being applied on it, and it will tell you if it is going to break or not. But design is something different. In design, we have the load and we want to construct a chair that will sustain that load. So that's like one more step higher up than analysis. We haven't expanded over there yet, but that is kind of the ultimate goal.
I'm more interested in the building side of things.
Yeah, so this is a similar concept with buildings too.
Would a structural engineer end up using this, designing this building, and signing off on it, putting this stamp on it?
Yes. So once you have the design pipeline implemented on top of it, they could do that.
Can you explain the 18% that said either no or maybe? What were their concerns? That's my first question. And the second is, can you help us understand that you understand the risk with this type of project and with it just typing in a couple words, your liability? So first the 18% and then understanding if you understand the liability.
Okay. So in this survey that we did, we also had a comment section. Not many fill it out. There were like 4 comments and most of them were about trust, right? How do I trust it? Right? With all the softwares, I know what I'm doing, but this is just taking my English prompt and doing the simulation. So, and I want to claim that concern is baseless because we are not, our agent is not coming up with simulations from scratch. It is doing the pre-processing part of it. If your prompt is clear, if your prompt is well bounded, it is going to do the exact same thing that you tell it to do. Now, if your prompt is not clear enough, if you are missing some values here or there, it is going to search the web and figure out a relevant value and going to use it, right? So, sorry, I forgot your next question.
Liability with such a, when dealing with structures,
Right.
There's a lot of liability that comes with that. So taking this on and putting this product out into the industry, is there a disclaimer you're going to use so that someone just doesn't pop in a design and they forgot to say Florida or they forgot to say Alaska and all of a sudden they're relying on this design that may not be correct?
Right. I think that's more of a concern for the user who uses it. Like even with the existing tools, right? If one of your geometry is not as what you intended, even with the existing tool, it is going to give you something similar to that. If your prompt is not what you exactly want to do, then it is going to do something different. I think that is already a problem with, not a problem, but issue with existing finite element softwares, and that is also translates to our software.
And just to add on that, like we are again not generating, we are not asking the agents to generate the whole physics engine from scratch, right? We are using a repository which we have not mentioned it, but there will be a repository of well-researched engines that are coming from top-tier researchers and industry. And we are actually building that repository which is open source today, right? And all these market tools that we have are basing on that. So what we are doing is actually building that repository and democratizing that to make sure that the agent is basing everything based on that. So basically, the engine is well proven. So it's not generating something from randomly from the web or something as such.
Good job, guys. I can see you're very passionate about this, and it brings back some painful memories from Georgia Tech. I can tell you that. So we've studied this stuff. But so anyway, so how would you market this product, and who would you market it to, and the people that you're trying to sell it to? Are you taking business kind of away from what they really do, or does it supplement what they're doing? How does that kind of work, and how would you make a revenue stream out of that?
Right. Our current market that I see right now is people who do research with FEA like myself, right? Every day I spend hours writing finite element codes for different problems. Right now, my workflow is completely overhauled. I just prompt it, give it good prompts, and then it will do the thing that I exactly want it to do. So a market that we can target right now are labs like the one I work in, where people don't want to waste time doing menial tasks. Then the next market is for students. Let's say our student wants to design a table, for example. But to design a table, they're going to have to go through a steep learning curve of using those softwares like Abacus and ANSYS. Instead of that, they could just type in what they want to analyze, and then our system, our framework will do it for them. And the next step is to obviously expand it to the industry. For that, we'll have to add the design layer on top of the analysis, and that is also that's a work in progress.
More time? One more minute so that we can have another question. If Judge has another question they'd like to ask.
I'll ask one more question.
Sure. Elliot.
So right now, I'm dating myself a little bit here, going back. Is this more like, are you talking about like statics right now than you are about concrete and steel design? Like you're just identifying loads versus members that you're actually going to incorporate in the structure.
So this tool right now, it is not about design. It is about analysis. So you have a particular structure and you know the load that are going to be applied on it, and you want to figure out how it is going to behave, right? So this is not only used in civil engineering, it is used in aerospace, it is used in mechanical. Let's say you have a frame of airplane. You want to know what the stresses are when air passes through it, right? So if you know the exact geometry and the velocity of the air that is passing by, you can find out the stresses, and you can figure out whether you need to reinforce a certain part of it. But again, let's say you're designing a building and you have a particular code. That's one problem on top of this. So you need to incorporate codes of practices like ACI on top of this, and then you will get the entire design.
Okay, thank you. And now we go to the award founder question.
You guys are obviously very, very smart, and I'm left with what's probably a pretty stupid question because I don't completely understand this. But are you trying to sell a software product to, say, a structural engineer to use independently, or are you trying to sell a software product that would fit and be part of his existing design tools?
Right now, it's the latter. So right now, it's just the analysis part of it.
So does that make your customer the software provider instead of the engineering firm?
Not really. So, for example, our competitors like Abacus and ANSYS, right? So they are used for analysis of structures that don't really have a well set of course of practices, right? For design, you just put in a structure, follow the code, you get the member thickness, you get the reinforcement that you have to provide. But the software, what they do is, let's say you have an arbitrary geometry with arbitrary loading. There is no course of practices that you can use to figure out the stresses on those kind of structures. So this is for this right now is for the analysis of the structure, which is one of the pipelines before design. So right now in the phase that it is in right now, it is one part of the entire pipeline, which we could sell it to the industry, but the goal is to add the design pipeline on top of it and sell it as an entire package, which works like, let's say, ETAPS or SAP or Revit.
So just to add on that quickly, so for sure it's a software-based software-based tool like how Abacus and ANSYS are, but we are trying to fine grain that to a level of cost of a simulation. So if I just want to run a simulation, maybe let's say few simulations, I should be able to run that without having to grab all these expensive licenses, right? So we are trying to bring the cost of simulations and doing this analysis of the different structures at the level of per simulation cost rather than going into buying licenses, like expensive licenses. That's the software side and making it more fine-grained towards per simulation cost-based models.
Okay, thank you, Fearless. I've been watching this sheet tear for the past 15 minutes. So for all of us, I'm going to tear a sheet. Next, we welcome up the second of the Higginbotham Award. Higginbotham Award finalists. We have HydroLoop, Anuj and Robbie, and I believe Anuj is going to kick it off after they hand out their supplies.
Hello, I'm Anuj Patel. I'm a civil engineering major with several internships in construction and development.
My name is Robert Hauf, and I'm a mechanical engineer with experience in product design and development in the automotive industry, as well as manufacturing. And we are the founders of HydroLoop, a modern approach to dust suppression. So the current issue with dust suppression is that the main approach is a largely brute force. It's inefficient, and it relies on manual intervention to adjust the nozzles. Now, why is this a problem? Over just a few months of deployment, this results in over millions of potable water being wasted, thousands of dollars being wasted on excess labor, fuel, and water, and all in all, a lack of management of the moisture levels within your soil. Now, our solution relies on a three-step process. First, we need to sense the moisture levels, we need to properly dose the soil, and then we need to collect data. So for moisture sensing, we're going to do so through the use of a thermal camera. And I'd like you guys to reference the prototype that we have placed in front of you. So the difference between water and soil for our purposes is the heat capacity. So as a result, wet soil tends to be a lot colder and is more resistant to increases in temperature. So we take advantage of that by using a thermal camera. And this is our prototype that's shown here. And it's a thermal camera, which in these images shown in the figure 1, we can see that we can properly identify the wet and dry regions. And this is this is indicated by the red LED indicators. Now, using this technology, we are able to shift this into a proper dosing format. So looking at this graphic below, we have an array of solenoid valves, which converts a thermal gradient from the thermal cameras into very discrete and specific regions that correlate with the spray zones of each of the nozzles. So we will essentially be able to determine for each region in front of the nozzle whether the soil is wet or dry, and then be able to determine which nozzles to open or close to only apply water to the areas that are dry. And we can do this automatically. So as the operators are driving around, their operations remain the same. And this is automated to only allow water to be sprayed in the areas that need additional water. Next, this enables us to do more advanced data collection. So we'll have a secondary thermal camera with the user interface within the cab. placed on the front. And in doing so, we can give live tracking of the thermal readings, which correlates with the moisture, to guide operators in the direction to areas that need more water. At the same time, we can do site-wide tracking. So this helps for several reasons. This helps with compliance tracking. It helps with understanding which areas of the job site need more water or less water. And then additionally, it allows us to advance our models. So we can educate our own model to enhance our moisture data, and also at the same time, apply into other industries and other applications. And next, I'll pass it over to Anuj, who will handle the business aspect of our policy.
So HydroLoop hopes to address a $204 billion market, which is the site excavation market and site preparation market, where all of these projects have stormwater prevention plans that include dust control. When developing HydroLoop, the customer impact and return on investment was a top priority of ours. In terms of saving 25% in water and 15% in fuel and labor, we're able to create a 167% return on the customer's investment when integrating HydroLoop into their dust control. This translates directly to about 400,000 gallons of water being saved and about 1,000 gallons of diesel, followed by about 20,000 pounds of carbon emissions, which is tremendous for the local community in terms of preserving air quality and the environment. When looking at a financial perspective, HydroLoop hopes to break even in year 2.5, with the operating costs during the first year being about $100,000 and the second year being about $300,000, which is why we're asking for a working capital of about $470,000 to get to a point where we're self-sufficient and profitable. Our current model uses a $500 monthly model where the client would add it on to their rental of their water trucks, as most water trucks are already rented. And so we feel like that would work best with the project life cycle of site development projects. And it would also minimize any maintenance concerns or also any high upfront costs for the capital, and also allows us to make sure that the consumer is able to try out our product and like it. And then also we're then the asset owners, which allows us to have a recurring revenue model and also depreciate the asset over time. And so our goal at HydroLoop is not only to minimize or maximize the efficiency of dust control on sites, but to work towards a future where we can implement our models into other aspects, whether it's landscaping or reusing concrete washout water, and then understanding how maybe we could also move to a future where we can fully automate the process. And so we're excited about the progress we've already made and are happy to be here. And we'd like to thank you guys for giving us the opportunity to be here.
Excellent job, guys. So now we're going to pass to the judges for questions. Elliot, I believe you're first.
Right out the gate. So I'm going to look at the numbers a little bit here because conceptually I think it's good. I'm imagining when you talked about the contractors, are you talking about the folks that are actually disturbing the land in that regards? So those projects are ginormous, right? They're huge. They get massive contracts. I got friends that are in that business, and the numbers like 500. What's going to resonate with $500 on this device relative to the size and scale of these projects that they're doing?
Right. So if you'd like to turn to figure 2, we have our financial projections in that. I personally have been on a site where we were disturbing land on 120 acres. We moved about 1.3 million cubic yards of dirt on that. Our analysis here is just a 5-month project with 1 water truck, but obviously it compounds with more trucks that you might have in a longer timeline. Like personally, when we were on that project, we had about 4 water trucks. And so the goal here is to make sure that no matter what the scale of the project is, there's still a benefit for the customer, right? And so a $500 cost to save $600 or $6,000 over a course of 5 months. Like we see that being able to compound if you have 3 water trucks, if you're now disturbing land for 9 months rather than 5 months. And so overall, we see that no matter what the size of the project is, there will be a benefit for the customer.
Yeah, so $500 a month on a project like that is
nothing.
Nothing.
Yeah.
Why don't you just sell it to the water truck guys? Why is it part of this rental? That's what I was wondering.
Yeah, so like right now, most water trucks are rented. And so obviously if you're working with a plateau excavation that own their own fleet, like we would obviously work with them to sell it outright. But a majority of heavy civil equipment is rented. And so we want to make sure that that's not a barrier to entry. If someone is only going to use a water truck for 5 months, it might not make sense for them to pay $4,000 for our equipment, right? And so that was kind of the thought process of that, but obviously it's still open to like
what I was wondering was if they're renting a water truck, then the water truck company, whoever is providing the equipment,
right?
Why doesn't he just install it?
Yeah, so the way it would work is like if you're going on a ski trip and you're renting a car, like the rental company would ask you, would you like to add on snow chain tires, right? And so that's how our model would work. We would work directly with the rental agencies to then ask the client, would you like to add the HydroLoops, like retrofit onto the water truck that you're renting?
So obviously this is a tool that attaches to a water truck. So do you own or do you have a patent on all the components of that tool? And then two-part, can you talk about the attachment? How does that attach onto a random water truck? How did you figure that out?
Sure, so I can take that. So from a intellectual property perspective, we haven't yet, we've begun the process, but we haven't gone through completely. But a lot of our technology, we're reusing components that are previously existing. These solenoid valves are components that we'd be buying. The thermal cameras are already components that we'd be buying. So from a component perspective, there isn't an intellectual property opportunity. It's with the integration within the whole system that is our opportunity. And that's what we're going to be pursuing in terms of intellectual property. And as for integration within the system, so we're not reinventing the tubing aspect. So there's the central tube and then there's the valves that offshoot. So we're trying to generalize that tube and also have general fittings that allow you to connect the previously existing water connections directly into our system. So trying to keep that very uniform allows us to be able to integrate into every system.
Thank you.
So another one that hits close home to me because I'm in the heavy civil business, like I said. So dust control is also a big issue on sites, especially where neighbors and all are involved. So have you thought about in the age of drones nowadays, you know, putting this on more of a global kind of concept where maybe you take your moisture content kind of readings thing and set it on a drone and you feed that into an overall CAD model for the site that you can maybe pass down to the operators on these trucks to get a little more definitive kind of area that you're gonna cover. Have you thought about that?
Yeah, absolutely. So we've thought about that. And part of that comes down to a lot of the, like what we're working on might be roads or something like that. So you're already going to be doing the passes. And if we are already running our trucks throughout these consistent passes, then we're already going to have the sensing data already done. So we've thought about expanding to drones as well. And the only issue with that is really comes down to limitations of the thermal camera. So there's a limited range or distance that you will have very clear resolution of your images. And because of that, you're going to have to fly at certain heights. And also to kind of coordinate that, it might be difficult with the limitations of those sensors. However, this is something that we're going to continue to consider and see how we can use those thermal cameras to the best of their abilities to be able to apply that as well.
Other gut reactions to that include that like a lot of drones have a limited battery capacity of about 20 to 30 minutes of flight time. They also, our goal is to make the product cheap and easy to implement. Obviously, drones are very expensive. We don't want our project to cost $10,000 to implement.
Good answer.
Scott?
Where are you guys in your business startup? You started up in patents, that kind of stuff.
So we're still in the process of that. So we're early on in development. We're building out our models and really finding a strong correlation between the temperature data and the moisture. And so once we're able to really solidify that data and build out those models, which we already have very high confidence in the ability to do those. We've proven them on a small scale. We're working on scaling that so that it's applicable to the sites. And so once we're able to do that and further build that, that's when we're going to be shifting over to intellectual property.
So I think there's time.
Can I get one more?
Yes. Elliot.
I want to make sure that we also talk about what it is that you're trying to accomplish here. So the device is attaching to the back of the truck, which is, I don't know how wide it is. Is this more of how on a micro level, how much variation do you really get in the moisture of the soil based upon essentially the width of a truck? Can you talk to us about that on the sites?
Sure. Yeah, so that's something we're going to continue doing analysis on, but we're confident in the results. And a big reason for this is that we typically use a brute force approach on the sites where you're essentially spraying even if all the soil is already wet. So that's going to be the biggest advantage, that when it identifies that the entire soil has already been sprayed and you don't need additional water, it'll completely close those valves to prevent just continuing spraying areas that are already wet. So, and then you can also dive into specific areas. So one situation in particular, when you're driving the vehicles across and you're packing down certain areas with the tires in particular, you're also changing the thermal properties. And so you're going to have areas where you have repeat traffic, are going to be areas where you're going to have to have different temperatures and different moistures because the heat capacity and resistance to temperature change is changing. So that's going to be a primary. But overall, it's really that overall, widespread overspraying that we're trying to limit, that will be solved through this system.
To add to that, the typical width of a truck is about, for a 4,000 gallon tank, is about 7 foot. And so there's going to be space between that truck. Also, it's not like it's a paved road, like every single time they drive over it, it's going to be a little bit different. There also might be a 740 loader that is going to have maybe the tire itself is 7 foot wide there, right? And so there is going to be a lot of variation in terms of what that path will look like. And within, even if it's a 1 foot by 1 foot block in terms of what each nozzle is handling, there will be variation in terms of seeing that. There might be one area where a truck is able to go by and no sill is pushed up, and instead it might be compacted. There might be another area where the truck is turning a little bit, and there might be some sill that's gotten up in that area too. So,
do other judges have a question they would like to ask? I think we have another couple minutes. 1 minute. Please. Kelly, did you have a question?
Sounds good.
Okay, then we'll pass it to the award founder.
So I think I understand what you're doing. From 30,000 feet, we're taking the least technical piece of equipment on construction site, operated by the least skilled operator. A lot has to go on here in terms of the thermal cameras and the electronics or the processing that causes this to run what I think is relatively automatic.
Yes.
Where is all that technology and how sensitive it is? Because you're talking about the word brute force has been used a lot here. Driving a water truck is a brute force exercise. How are you going to keep the technology such that the driver doesn't have to intercept it or make any adjustments to it, and it's sturdy enough to survive the environment?
Absolutely. So, I mean, the beauty of our idea is that the technology is relatively simple and it's automated. So from the operator's perspective, their operation of the vehicle doesn't change at all. Like from looking at the back of the truck, you're going to have the valves open and close automatically, and it's going to be reading the region in front. And so for the operator's perspective, they're going to be doing the same thing that they always do, no difference. And also, we did consider concerns with, let's say the sensing is not working properly. Let's say something has happened that it's not working in ideal conditions. And what do we do if now you're not having your valves open properly? Then we go back to the original brute force approach, leave all of them open. And so that eliminates the concern for something not working properly, because you have the ability to immediately back out with a flip of the switch and leave all the valves open and go back to your original process.
And to add on to that, yes, it is probably the least complicated item on this site with maybe the least skilled labor that's also operating it. But at the end of the day, there's still a lot on the line here. Whether it's using resources that are water that a lot of communities are already facing an issue with. Oftentimes, a lot of the other considerations include the environment now, and so even though it is the least technical aspect, there's still a lot to lose in terms of just wasting resources if it's not optimized.
Okay, thank you so much. So thank you to all the teams. I think you've made the judges' job very difficult. These have been great pitches, so thank you very much for that. Now our judges need some time to deliberate. So how that's going to work is we're going to ask people to leave the room. The judges will stay in the room. Don't go far. And you might have been asking yourself, hey, I had a question for these teams. Well, they will be outside and hopefully very happy to answer your questions while the judges deliberate about who's going to be the winner from among the 4 finalists. So for now, we ask everyone to please exit the room, the judges to stay, and don't go far. We will get you back in probably about 15 minutes. All right, welcome back. Judges had a very difficult job of deliberating. I was here in front of them hearing the argumentation. But before we announce the winners, we do want to talk a little bit about where these prizes actually come from. They're made possible by Bill Higginbotham, who's here today, and Greg Zeitlin. Bill Higginbotham is a 1976 graduate of the School of Civil and Environmental Engineering and a serial entrepreneur. I actually call him sometimes a parallel entrepreneur because he usually has multiple ventures going on. Started over 13 businesses focused on geotech, consulting, energy and environmental management, construction, and venture capital. Bill's been involved with the school through the External Advisory Board and is co-instructor of the Innovation and Entrepreneurship in CEE Systems course, which we co-teach actually together. Thank you, Bill, for spearheading these entrepreneurial efforts in the school. So that's for the Higginbotham Entrepreneurship Award. The second prize was established by Greg Zeitlin in honor of his parents, Phyllis C. Zeitlin and Alan G. Zeitlin. Alan was a 1962 graduate of the School of Civil and Environmental Engineering. He had a successful entrepreneurial career in construction and real estate here in Atlanta. The Phyllis C. and Alan G. Zeitlin Prize honors Alan's appreciation to Georgia Tech for helping him launch his successful career and presenting the opportunity for him to meet Phyllis, his wife. Many thanks to Greg Zeitlin for establishing this prize in honor of his parents. So now I guess is the moment that you've all been waiting for. We'll announce the winners of the 2026 Entrepreneurial Impact Competition. Don is in the front to give out the award to the Zeitlin Innovation Award winner. That award goes to OmniTherm. So we're going to welcome you up to the front. There will be some pictures involved. Congratulations. So this year, unlike in previous years, we had so many great teams submit. We wanted to acknowledge both of the finalist teams. And so we have some really nice finalist framed awards for DozeOn as well. So we'd like to welcome you also to the front, Alani and Andrea. Now we invite Bill Higginbotham up to distribute the giant check. This year's Higginbotham Entrepreneurship Award goes to HydroLoop. I don't know if you want to stay up, but we're also going to be awarding to Fearless, the finalist. Yeah. I'm going to pass it to Don. I think Bill also wants to say a few words, but I just hope everyone has a great launch of these startups. We happened to see that Artemis 2 had a successful launch while you guys were out enjoying your drinks. So, great job.
As I got closer and closer to the school, I kept trying to come up with good ideas. I kind of boxed it in on the course I teach. Because I bugged him to death, and he said, okay, if I agree, will you teach it? But this followed that. And this whole process was trying to create some sense of reality, some sense of incentive to coming up with good ideas, because I don't think the school was doing it. Your incentive in Georgia Tech for a good idea is to get an A and get out. So I really wanted to create something that create something tangible. $5,000 isn't a lot, but it's a start. But it's a direct result of somebody coming up with an idea, prosecuting the idea, and then winning the prize. So I look back 6 years. We've seen lots of good ideas. Saw a couple of crazy ideas, but it's working. And what I'm going to continue to do, working with management here at Civil, is to try to find other ways to do the same thing. We want to create more of an entrepreneurial culture here because it is so incredibly important. Being a good engineer is a great profession. But being an entrepreneur probably means you have created a greater realm of success around your engineering career. So very happy with where this is going, and we want to make it grow bigger. Bye.
Thank you, Bill, for spearheading this effort from the start. I will just add to your comments to say that the impact that the student teams have had after this competition has also been pretty impressive. We've had teams go on to win national level awards with ASCE, so just continue to develop their idea and polish it and present it to a bigger and, as I said, national audience. We've also had teams that have gone on to actually start a company. So please aspire to continue to develop your idea and to move things forward. Okay. So thanks for everyone for being here this evening. Let's give one more round of applause to all of our teams for their innovative, impactful, and interesting proposals. Thank you to the judges for bringing your wealth of knowledge, your experience to our students, and for your thoughtful deliberations for selecting the winners for the two awards this evening. I hope that everyone enjoyed the competition, and we appreciate your support of our students. We do have a live reception during the break as the food was covered up, but it is now going to be unveiled, so the judges can enjoy some as well. So please stick around and enjoy conversation with the teams, and thank you all again for coming.